So, hello everyone. First of all, thank you so much for being here. Fabio already welcomed you all. Today I'm going to talk you about a little bit about GitLab Runners at scale as a service when you need it to go big. Where this came from? Basically, this came from an implementation that we did for a client. Fabio already mentioned it. Basically, we did this use case for Mercedes-Benz where they had a very specific needs in terms of GitLab runners. But yeah, we will get a little bit deep into this implementation, specific implementation. I wasn't here since the beginning, but this was a project started by us, started by other people. Then I joined the project since last August. Okay. Just a little bit about me, who am I, sorry. So my name is Serra, I'm a DevOps engineer here at xgeeks since 2020. Cloud native enthusiast, whatever this means, so they asked me no, I'm joking. No one asked me to add this. Just to give a little bit of sense about you, about yourself, and about your expertise with CI/CD. Does any one of these icons or logos, whatever, does any one of these ring a bell on you? That's cool, that's cool. Okay, for those who don't, so basically these are CI/CD tools. There are some of them that doesn't have any name. TeamCity from JetBrains, GitHub Actions, probably, if I say the names, probably you will associate to the tools. Jenkins, Run CI, GoCD, for example, GitLab, of course, Buddy, and so on. And for those who raise their hands, these names also ring a bell on you? Okay, okay. So basically, this is to distinguish between who use these platforms and who configure them. Basically, most of you probably are developers, and when you commit your code, there is a pipeline. There are other names, okay? But there are one pipeline that will be triggered that will run a bunch of steps. Let's say that will build your code, perform lint, compile, blah, 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 create a container, a Docker container, and basically each one of these tools will have agents, runners, executors, basically, where actually this code runs, or this instructions runs, sorry. And for this purpose, of course, I already mentioned, so we will be focused only on GitLab Runner. So I made this introduction just for you to understand. So for example, there are some people that that use, for example, Jenkins, and they know the word agents, but they probably cannot understand what the hell is a runner. So here we are always all in the same page, okay? Okay, so let's give a little bit more context to this topic. So probably you are one of these cases, okay? So you have your team push the code into the GitLab. Let's assume GitLab for this use case, of course, and then you will have the GitLab runners or the executor things, let's call it this way, running somewhere. Let's assume on a Kubernetes cluster. But then you start to have issues with isolation, that you will need isolation for each one of the teams, okay? Probably, and this is probably because there are no one single use case for each one of these implementations, you will have something like this. So we have two teams, each one pushing the code into their GitLab project, and then you have these runners split, let's say, for example, into different namespaces, if we are talking about Kubernetes. Or you are just using a machine with some Docker containers, because GitLab runners can run into multiple platforms. It can be a shell script, it can be a container, it can run in many places, okay? Of course, if you have the same isolation needs, also you can have different pods running into different networks, whatever. But let's say that, okay, containerization is not enough and you need access to the operating system and your pipeline performs some syscalls, I don't know. Probably you'll need something like this. Just a server running inside your organization with GitLab runners, usually typically running on a shell, for example, can be a Linux service. But I have isolation. Okay, doesn't matter. Can have VMs. We can have two machines. Okay, but my company is a full cloud, or yeah, it's a very nice company. We are very young and dynamic, and we want to go to the cloud. Okay, so probably if we are talking about AWS, and now I'm using AWS example because it's what the client actually uses, you can have something like this. So 2 virtual machines running inside the cloud provider, and on AWS it's called EC2 instance, okay? But what happens if those developers approach you with this question? That's not enough, okay? I need a machine to run my pipeline and I demand at least 1 terabyte of memory. You have 2 options, so, or you can say them, no, actually you have 3. You can say no, and you are fired. You can say, okay, this is very expensive, I will buy some equipment to have in-house, but that equipment you need, probably it will break, you need to update it, or you can move to cloud. But 1 terabyte of memory on cloud is actually very expensive. When I say expensive, actually I was talking with my PO this afternoon, and there is a project demanding for not 1, but actually 10 instances of this type, and each one of them inside AWS costs around 2.5K per hour. So you can imagine the amount of money that you spend at the end of the day. So basically, let's say that they ask something for this. I need bare metal execution that are actually required to run my jobs. My build jobs are not prepared to be containerized because here, just to give you some context, so I'm not sure and I don't know all the projects that actually are using our runners because we provide runners as a service, like I said. But in this particular use case is like people or teams that are building, for example, the infotainment of the car's infotainment, okay? So basically, that's an operating system. It's built on yacht code that can build some Linux distribution. I'm not the correct guy to say all the needs, but actually this, or all the specification for this technology, of course, because I don't work with it, but basically these are some of the requirements that they approach us with. I have special requirements, or I have high and complex workloads, of course, that you have because you need 1 terabyte of memory. And I need cache, and I generate a lot big builds, and it's not fitable to be always building those builds. So I need persistent and not persistent storage. I compute resources. So I need this scalability, but I need it to be as cheap as possible, okay? And since we are using GitLab, we found this. As I said to you, so GitLab has different executors. You can have shell executor that basically is a service running inside a Linux machine, a Linux server. You have a container executor, I think it's the name, where you can have it running on a Docker. You have Kubernetes executor, and then you have this instance executor. Actually, this executor is still in beta. I think it entered in beta this month or last month. The last month, we are in February, it was in January. Until there, it was still in experimental. And this comes from their documentation. Autoscale enable executor that creates instance on demand. Perfect, that's cool. Okay, to accommodate the expected volume of jobs that the runner manages process. That's cool, I don't know how many jobs they want to to run. Use it when jobs need full access to those instances. Yes, that's one requirement. Operating system and attached device. They need storage. Okay, I can attach some disk. Can also be configured to accommodate single or multi-tenant jobs with various levels of isolation and security. That's perfect. So basically, I still have this isolation and I can accommodate several teams. And I have all the remaining things, okay? And looking also into their documentation, basically they say this. To use instance executor, there are 3 steps. Install a plugin, and basically these plugins are based on cloud providers. Actually, I said something wrong. AWS plugin is the only one in beta. The other 2, it's still in experimental. Ensure that this plugin is discoverable through path environment variable, and then create a virtual machine with Git, GitLab Runner, and everything that you want. Basically, is what this is saying. So let's focus on the first step. Install a plugin. Basically, it's just a GitLab Runner with a plugin installed. Basically, this can be a container, okay? If you, I'm not showing you the Docker file, but it's just from, for everyone that already created Docker file, it's just from GitLab Runner, get one of those plugins, install, export path, blah, 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 blah. It's on that place, and that's it. This is the first step. The second step I won't show you because, yeah, it's just to export and make sure that that binary is discoverable through the path environment. And the third part is like they say, you have to create a virtual machine that has these 2 and some things that you need, okay? Basically, on AWS, this is called AMI, Amazon Machine Image. It's like, it's like a virtual machine. It's like a snapshot of a virtual machine. I don't know if this is the proper way to describe it, but basically, okay, I have Git, I have GitLab Runner, and GitLab Runner not with a plugin, just the executor itself, and some dependencies. I don't know, some, for example, if you are talking about a C++ project, could be like CMake, GCC, compilers, and so on, okay? To do this, or just to approach or to achieve this thing, or this part of the setup execution, we use Packer. I don't know if you are familiar with it. Basically, it's a configuration as code tool where you have like a description file and you get, for example, a Ubuntu-based image, get me from Ubuntu. And if you use Mac OS or if you use Linux, you can add a bunch of instructions like apt install git, apt install GitLab Runner, apt install CMake, wherever you want. So basically, it's just a wrapper to help you managing these AMIs, okay? But now, talk is cheap, and now I'm going to present to you what, in terms of architectural and actual implementation means, okay? So I don't know if this is too small, sorry about that, okay? Let's start, or let's come back to the beginning of the presentation. I have here a GitLab with my team project or group. So basically, a group can have multiple projects. It's very similar to GitHub that you have repositories and organizations. I think this is the relationship between them. And an empty AWS account, okay? So in this case, this was the stack. They are using GitLab and they are using AWS. First of all, I want, let me get back just to help you. So I need this, wait, I'm not seeing the same thing. Okay, I'm not seeing the same thing, sorry. I want this guy right here, basically is a GitLab Runner with that fleeting plugin installed. This given container, okay? Basically, what we did was that. Just a repo that we called GitLab Manager with a Docker file that just builds that images and publish that images into Elastic Container Registry. Could be here, it could be on Docker Hub, whatever. We use all the things inside the AWS because it makes more sense to use all the things, okay? So we have the Docker or the GitLab Runner Manager, as we called, image ready. We need an AMI, right? Okay. A repo called AMI Packer with some Packer files, all the instructions, that will help us to build and publish AMI images into the AMI catalog. Basically, these are pretty similar. This is to Docker. This is for Docker images or container images. This is to virtual machine images. Next, and this is where things are start to complicate. So basically, we divide this into implementations, and I will explain you a little bit later why. A first instance or first step in terms of infrastructure is to bootstrap or to apply common things, and you will understand what common means. So secret managers to store, to store those API keys, to store that sensitive data. S3 to have some kind of cache. Let's imagine that they don't want to store things on disks, because on disks you have to deal with the attachment to the virtual machine and so on. So they just want to store some files, an S3 bucket, and the Lambda function. I won't cover this Lambda function, but basically this is an housekeeping process that will, several housekeeping process that will run through the time. For example, to clean old AMIs versions that are not used anymore, and so on, okay? And this Elastic Container Service. So basically the first container that we created, that GitLab Runner Manager, is just one thing. It's just a container that is running, okay? It's just a container that is running, registers against a project or a group, and it is waiting for jobs, basically. This is what this GitLab Runner Manager does. And once, okay, let me go a little bit further. So basically, once it's running, it registers. You will pass, of course, the token, all configurations. So this is my Git instance. This is my project. This is my group. Blah blah blah. And these are the token, and so on, so on. All the things. Basically, they will register into the GitLab and is waiting for someone to trigger any pipeline. That trigger pipeline, it means it depends on what you basically define. It's on pull request, it's on push, it's on commit, it's on tag, it's on whatever. And once this container receives, or once these services, receives any pipeline, any pipeline to be executed, basically what they will do is they will manage this auto-scaling group, basically increasing the number of instances of this scaling group by, I don't know, 1, 2, 3, 4. It depends a lot on your configurations. And basically, it will send all the commands through SSH into this EC2 instance. Okay, and this way. So let's imagine, or let's get back into the scenario where we need a machine with 1 terabyte of memory. Without all this stuff, basically what you will have will be something like this. Spin up an EC2 instance with an executor inside, always running and always waiting for pipelines that runner will register directly into the GitLab project. Or we can have this where the auto-scaling groups can scale until 0. And once you have actually the need to run something, this run manager will scale this auto-scaling group by, let's say, by 1 machine. That machine is spin up. It sends all the commands that must be executed through SSH. The commands are executed, pipeline is finished, okay, failed, success, I don't know. And this instance is killed. Okay. Then you have a lot of configurations that are more related with the GitLab itself. So how many? So what is the thresholds of this auto scaling? Do you want any idle instance that is always running or not? How many machines can it scale up to? How many jobs can run multiple at the same time in one machine? So these are a lot of configurations that we can, if you want to know more details, that we can discuss it later. Basically, it's GitLab specific configurations. Okay. Just as a summary, so motivations, of course, I already passed through all of them. It's scale. It's a scaling solution because it's based on one of the most common, or I won't say common, but common or famous cloud characteristics, that is scaling. Customization, solution customized by the tenants. So what we are providing to them is like we provide the base AMI with the Git and the GitLab Runner installed, but all the custom tools that they need, they are able to go to this repo and add whatever tools, whatever versions they need, okay? Tenant isolation in terms of resources and costs, and this is very important. So, for example, the approach that we are following is each project or each team has its own AWS account. Pretty simple isolation, but basically the bosses on Mercedes, they know, okay, this account belongs to this project, this account belongs to the project, so the costs associated to that account are coming from those guys or those guys. Based on needs, all clients are different. Basically, this is just a summary of everything. All clients are different. What we mean with this is like with this solution, I don't care what kind of EC2 instance you are using. If it's a Linux-based machine, is up to you. If it's a Windows-based machine, is up to you. I don't care. Basically, I already have the Packer commands or the Packer commands or files to both of them with the base for the Linux and for the Windows. And if you want to customize, please do whatever you want, okay? But these also have challenges. And some of the challenges that I'm now talking to you, they are not finished, they are not solved. These are actually needs and challenges that we are facing at the moment as I'm speaking. Observability, how to provide observability to the project. So if the pipeline failed for some reason, or not for some reason, but due to infrastructure problems, how can we provide that observability to the client? Because let's say they can choose the type of instance. The type of instance on AWS for those who use is like if I want a machine with 1, 2, 3, 4, 5 gigabytes of memory, and let's assume that the client doesn't choose the right one, or because it's not enough, or the opposite. Just to run, I don't know, Hello World is like, 128 gigabytes of memory should be enough. Of course that is. But actually it's spending money, okay? And this is the kind of things that we are trying to achieve at this moment, providing the right CI/CD observability. And as you can see, there are a lot of, there are a lot of things that can go wrong. This container can be killed. Instance machines can have issues. Let's assume that they are attaching a disk, and that disk just enters into, I'm missing the word. Let's say that disk cannot be attached for some reason. So this is the kind of observability that we are trying to do. Until now, we had CloudWatch to get at least logs and metrics from all these components, and we are at this moment trying to achieve the same, but using Datadog. Okay, this was a company decision. Rollout process, how to deliver because basically what we are delivering is just a Terraform module and some files of Packer. How to deliver an infrastructure-based product without impacts, but pushing the latest changes. So this is a very huge, this is a huge problem that we are facing at the moment. Basically, when we provide this solution to our clients, it's just a Terraform module on version, let's assume 1.0.0. But this is actively being actively deployed, and new versions are always coming like every 2 weeks. And we really want, especially in this phase due to debug problems and so on, we want to push our clients into the latest version as much as possible. But you don't know if they are running, so what is the correct time to do this? You don't know if they have any pipeline running at the moment. You don't know if they are comfortable of us directly changing their versions on their repos. So this is one of the problems that we are trying to solve this moment. For now, it will be based on documentation, but it is what it is for now, okay? Containerization, another problem. So for this client, we provide two kinds of runners. So one based on Kubernetes, that is to run the most common use cases that, as you can think about, compiling, building, Docker build, so on. But there are some guys that they say, okay, but I need more memory, and you cannot, the nodes that you select for the Kubernetes cluster are not fitable for our purpose. So we say, okay, you can run containers inside those VM. But it's not that similar, or it's not smooth to manage containers and limits and allocations inside those virtual machines. And we are getting some issues with that. And then knowledge. Not all clients are familiar with the defined stack. Basically, and this is a problem as well, because, and this is funny, because for me it was pretty clear that everyone who was setting up this kind of setups were, I don't know, some DevOps, something comfortable with the cloud, but actually some of them are not. And some of the times they just made changes that break everything, and they don't know why. It's another thing that we can do anything about this. So we just have to proceed to some knowledge transfer, trying to write the proper things or the right things into the documentation, try to guide them as best as possible, but it's not easy sometimes. For example, one service that example that I provide to you earlier about that project that they think that they need 10 virtual machines with 1 terabyte of memory. AWS by default has one thing called service quotas. What is service quotas? Is inside one AWS account, you can ask for an X amount of CPUs, vCPUs. And actually, they are burning this quota with only 2 machines. So this is the kind of thing that they don't know, and we have to help them, basically. And that's it, guys. I think my time is up. On that QR code, I think probably is the same thing that you already show, our website, Medium, and so on. Thank you so much. Thank you so much for your attention. And yeah, thank you.